Hello, my name is Ricardo Garcia. U10 and I are the Group 8. Today we are going to present our project for the course of Applied Regression Analysis, which was named as Predicting Pig Weight at the End of Nursery Phase based on weaning parameters. Weaning is the process of separating the litter from the sow at around 17 to 28 days of life, which in the nature would occur around 90 days. However, such practice is necessary to produce pork and meet the global demand for food. At weaning moment, they are vulnerable to stress consequences caused by the change in the diet, in the environment, as well as a low capacity of enzyme secretion and immunological competence, leading to high susceptibility to disease. The negative impact of post-weaning performance are related to intestinal injuries, increased gut permeability, microbiota imbalance, and decreased in nutrients digestibility and absorption. At weaning, many factors exert influence on feed intake, and these factors encompass health status, weaning age, environment, palatability of ingredients, form of diet presentation, water supply and quality, and stock density. Some authors studied have suggested that increasing weaning age from 12 up to 22 days can be an effective management strategy to improve wean-to-finish growth performance in a multi-site pig production. In addition, some feed additives such as spray-dried animal plasma and also zinc oxide are supplemented in post-weaning diet to support the piglets during this time. Given that, the aim of this project were to predict the weight of the pig at the end of nursery phase based on different weaning age, feed additives, and the pig's weight on the first 2 weeks post-weaning. Our goals were to identify which factors contribute the most to prediction the pig weight day 42, which is the common age of the end of nursery phase. And then we're going to be able to select the factors that could contribute to have a heavier pig at this time. This information could be very useful to pig producers to determine the optimal age to wean the pigs and what other strategies might be used to increase the pig weight. The dataset used for this analysis is from Carcia 2019, which is unpublished data. There were 544 observations in the dataset and a total of 6 explanatory variables, as shown in this table. X1 represents the weaning age. All piglets were weaned at the same day in different ages in the same commercial pig farm in a range of 17 to 24 days of age. X2, X3, and X4 represent the pig weight at weaning, day 7 and day 14 after weaning, respectively. X5 represents the dietary inclusion of spray-dried porcine plasma, which range from 0 to 5% inclusion. And finally, X6 represents the dietary inclusion of zinc oxide, which ranges from 2,000 to 3,500 milligrams per kilograms of feed. And our variable response is the pig weight at the day 42, as described before.
Our project will mainly perform 3 steps: model diagnostic, model selection, and statistical inference. We first diagnosed 4 models in 3 dimensions: linearity, normality, and variance. And then we making selection for a possible model based on 6 criteria by best subset algorithm and redo the model diagnostic again to evaluate the assumptions and performance of this new reduced model. If the select model is valid with any assumptions, we might apply remedy methods on it again with certain transformation. Finally, if we passed all the assumptions, and we will try predictions on parameters as a result and provide a statistical inference in the end. Now, let's get started. As you can see, this is the basic terms of our form model with all predictors. Weight D42 is our response model, is our response variables, corresponding to the x1 to x6 as our independent variables, and their coefficient beta. The pair plots on the right buttons give us a general picture of the linear relationship between these parameters by themselves. Then we started to check the residual assumptions individually. We can tell the residuals of form model has a constant variance verified by Brown four-cell test with the relative large p-value, but we will notice this form model looks validated to normality assumptions in histogram. It looks the histogram showing it's slightly left scaled, and it's also validated on the Shapiro test. Here, since that's one point we needed to notice. Since the replication of our model of our data will be the 561, so the replication of our data will be 561, so the total terms will be 561 power to 6 in total, which is overflow when we perform the lake of fit test. So we decided to leave the lake of fit test later on after we do the model selection to reduce some variables. Other than that, the regression line of the QQ plots looks tailed in the two sides here. So which is possibly because some outlines exiting affect the normality, but the quantile residuals plots looks doing well with there's no certain patterns showing up there. From the summary of the model, we will get a specific coefficient of each parameters of these models, and all p-values in this ANOVA table is quite small. Reflects these parameters as all significant to the models. R squared here is the 0.6822, and R squared adjusted is the 0.6785. So which indicates almost 68% errors are explained by these models, which is quite acceptable. Due to the slight variation to the normality, we decided to use the box cost test to determine the suggested lambda. As a result showing on the screen, it is 1.4848. After we perform the transformation on x, due to we have a constant variance verified before, we start to move to the model selections. And by the best, so we decided to use the best subset algorithm and compare with the six criteria in each candidate's models. We decided to choose the model finally we decided to choose the model contains the 5 predictors x1, x2, and x5, and x6, because the SSEP is relatively small, and it also contains the largest R-squared adjust, closest CP value to P, smallest AICP, and the smallest PRESSP value. And we get this so after we decide which reduced model we're gonna choose, we will perform some residuals assumption checking. Firstly, we will perform the lake of effect. As we didn't do initially. So the result is showing as what we expect. The p-value is 0.9937, which is greater than alpha 0.5. So we conclude the reduced model is good fitted. Then we tend to check the residual assumptions of this reduced model again to see if there's any validated assumptions here. As we can see, the quantile residuals plot still looks great. There's no any certain pattern showing up. The tails of the regression line in the QQ plot looks flatter than the form model. So, and there's apparently changes on the histogram of these reduced models. We needed to be notified that compare with the data of the form model, it tends to more symmetrical and normal distributions. So the performance of this ANOVA table and summary looks all the predictors here are much more significant than the form model, even though the R square values is quite smaller than the previous one, but it still makes sense because with the variables has been reduced, the R square adjusted values also gonna be reduced, also gonna be decreased. Other than that, in order to have a comprehensive of these reduced models, we will also do some additional diagnostic in three plots: additive variable plots, residual compare with the head variables plots, and the cooking distance plots to see the performance of these reduced models. From the additive variable plots, we will easily find out x2, x5, x6 has more significant helpful to this new model compared with x1. And in residual, compare with the head variables plot, we can define all these points lay out of the vertical line and horizontal reference line are outlines. And the area of the circles representing the observations influence on the cooking distance. And this over high red line showing on the cooking distance plots can be identified as the potential influential cases. Additionally, we will do the diagnostic on the multiple linearity by checking with the variance inflation factors in each selected predictors. It looks none of the VIF value is greater than 10, so therefore we can tell there's no interactions or multiple linearity between themselves. So finally, we conclude our reduced model as has a simple terms and a better performance than that of the form model. So now we'll move to our final steps. Based on this reduced model, we are going to make some estimation on each parameters and a statistical inference. By the matrix multiplications, we first get our beta hat in vectors. As a result, showing on the left, and its confidence intervals by each terms. And then we compare this beta hat with the result of the robust regression method. We find out that our estimation values of beta is very similar and closer to the result of the robust regression method, except there is only 0.4 difference in the interceptor terms, but it's okay because it's a constant variable, because it's a constant, and so it's acceptable. At the end, we will multiply this verified beta hat vectors with the x in vector form to get our result of the estimation y or estimated response variables to get our result showing up here to make prediction to answer our research questions.
Winning age was one selected predictors in the model to predict the peak weight at the end of nursery phase. This first find might be really useful for pig producers that are wondering if changes in this practice can represent a good strategy to improve the pig performance. Leviel studied the effect of weaning age at age of 21, 28, and 35 days on post-weaning count Escherichia coli until 10 weeks of age. In this study, piglets weaned at 21 days had higher counts of E. coli than those weaned at day 28. The count of E. coli during this phase is an indicator of disease status of the pigs, since this pathogen is the major on causing diarrhea in piglets. The long-term effect induced by early life interventions such as weaning age on microbiota composition and gut homeostasis become more evident in recently studied regarding pig production. Moreover, Mann suggested that increasing weaning age from 12 to up to 22 days can be an effective management strategy to improve wean-to-finish growth performance. Overall, in 2 experiments, changing weaning age reduced mortality and increasing market weight at 1.8 kg for each day increased in weaning age. Similar, Smith evaluated the effect of weaning age on growth performance and feed cost. Piglets weaned at 20 days were 6% heavier than those weaned at day 15, resulting in a 17% reduction in feed costs in nursery phase. Then, both findings help to justify that weaning age is a good predictor for pig performance. In the present study, both zinc oxide and spray-dried animal plasma, in this case of porcine plasma, 2 important feed additives supplemented for weaned piglets were included in the model to predict pig weight at the end of nursery phase. This is an important find because both represent feed additives alternative to the use of antibiotic as growth promoter in the animal feed, which is one of the biggest concerns in global animal production. As a conclusion of our project, it was possible to prove that weaning age and weaning weight are the major predictors for the pig performance during nursery phase. Older and heavier pigs at weaning will result in a heavier pig at day 42 post-weaning, regardless of all the challenges that the pig face in this period, as described before in the introduction. As a limitation of this study, we believe that the information regarding the feed intake of the pigs could improve our model. This is because growth performance and feed intake might have an interaction, and this was not covered by our model in this project.